Hello students, today I am going to talk about the subtractors, which is another combinational circuit. Subtractors are used to subtract bits. There are two types of subtractors available. One is half subtractor and the other is full subtractor. So in this video I am going to cover both the topics. First of all, let us start with the half subtractor. A half subtractor is a device which is used to subtract two bits. Let us assume A and B are two inputs, that is two bits. The output that we are going to get is difference and borrow. So a half subtractor is a device which is going to subtract two bits. Next is truth table. In truth table we are going to see that how two bits are actually going to be subtracted. So we have A minus B. This is the function which is going to be performed here. 0 minus 0. 0. Borrow is also 0. Next is 0 minus 1. As we need to subtract a higher value from a lower value, which is not possible without taking a borrow. So that means first of all we have to take one borrow. As we have taken one borrow, and borrow is always going to be taken from tens place to units place. So 0 will actually become 10. So now we need to perform 10 minus 1. In half adder as well we have studied that 1 plus 1 is equal to 1 0. Hence 1 0 minus 1 will be equal to 1. Or if I talk about decimal number system, in decimal number system 1 0 is equivalent to 2. So 2 minus 1 is 1. Hence the difference is 1. Next is 1 minus 0. It's very simple. 1 minus 0 is equal to difference 1, borrow 0. And finally 1 minus 1, and 1 minus 1 is 0. So this is first of all the truth table for half adder. Now let us talk about the equations for difference as well as borrow. In difference there are two entries where the output is 1 and we need to write down the expression by using SOP, sum of product. First is A bar dot B plus A dot B bar. If the value of variable is 0, that will be represented as bar. If the value of variable is normally 1, so that will be treated as a normal variable. Hence, the expression will be A bar dot B plus A dot B bar. The final output will be A XOR B, because this is the relationship of XOR operation. Similarly, borrow. There is only one entry in the truth table where borrow is 1. That is 0 1. Hence borrow is A bar dot B. Now let us draw the logic circuit diagram for that as well. This is the logic circuit diagram. First is difference, which is actually A XOR B. So we have used an XOR gate over here. Next is borrow, which was A bar B. So first of all we have taken a NOT gate. Hence we are supposed to get A bar. And the other one is B. Hence the borrow will be A bar dot B. So this is the logic circuit diagram for half subtractor. Next is full subtractor. Full subtractor is again the subtraction of two bits, but now the difference is subtraction of two bits where a borrow has already been given to the previous values. For example, we need to subtract 1 1 0 minus 1 1. So we want to perform this activity. First of all, 0 minus 1, as I have already informed you that 0 minus 1 can be done with the help of a half subtractor. So 0 minus 1, the answer was difference 1 and borrow 1. So that means this activity can be performed by using a half subtractor. Let us see how. Let us take a borrow. 0. This 0 will become 10. So 10 minus 1, 1. But now here we have now got 0. So once again let us take a borrow, 0. This 0 will become 10 and 10 minus 1 is 1. Now this activity can only be performed by using a full subtractor. That means the difference of 2 bits where a borrow has already been given. So the actual number was 1 minus 1 where a borrow 1 was already been given to the next value. So such kind of subtractions can only be performed by using full subtractor. A, B are the 2 inputs. B in is the borrow which has already been given to the previous term, and finally the next output will be difference and again a new borrow. So this is the truth table for that, and we want to perform A minus B minus B in. So this is the actual action that we want to perform over here in full subtractor. We actually want to perform A minus B where a borrow has already been subtracted. On the other hand, I can rewrite the same statement as A minus, let us take minus common, B minus B in. When I have taken a minus common, so this negative will become positive. So this is the actual operation that we want to perform. By using the second formula which I have written, it becomes really very easy to simplify and to rewrite the same truth table. 0 minus 0 minus 0, difference 0, borrow 0. Let me perform this entry of the truth table. 0, 1, 1. So this is the activity that we want to perform. So hence you are supposed to get 0 minus 1 plus 1 is 10. With the help of half subtractor we have discussed that. So now this is the actual relationship, 0 minus 10, which is not possible because we want to subtract a greater value from a lesser value. So we need to take a borrow. So please have a look over here. We have taken a borrow. So when we have taken a borrow, 0 will become 10. So 10 minus 10 is 0. Let me perform another example from the truth table. 1, 1, 1. Let me again rewrite the same statement once again. 1, 1, 1. So this is how you're supposed to calculate. Let me further calculate the same statement for you, how you are supposed to get the final outputs. 1 plus 1 is 10, as we have already discussed. Again, we want to subtract a higher value from a lower value, which is not possible without taking a borrow. Let us take one borrow. When you are going to take a borrow, as 0 was having a new entry as 10, similarly 1 will have a new entry as 1, 1. So what is 11 minus 10? You can perform the subtraction. 11 minus 10, 1. Hence, you will be able to simplify the same truth table by your own without cramming the things. Now let us write down the difference and the borrow. First of all, we need to identify where the difference is equal to 1. So 1, 2, 3 and 4. There are 4 entries where difference is equal to 1, and again by using SOP method, you are supposed to write down the final equation. Hence, A bar, B in plus A bar, B in bar plus A, B bar, B in bar plus A, B in. Similarly, you can rewrite the statement, the equation for borrow as well. 1, 2, 3 and 4. So again we have 4 entries where borrow is equal to 1. So you can rewrite the same by using SOP method. Now let us further simplify the equations for difference and borrow. The equation for difference will be exactly same as we have discussed in the case of full adder, where we were getting sum. The only difference is the notation. Earlier we have used C in, but now we are supposed to use B in. That is the borrow which has already been given. So from the first two variables, take a bar common. From the next two variables, take a common. So this is b XOR b in. This is b XNOR. So you can see it over here, XNOR b in. Further again, we are supposed to have an XOR operation, that is a bar dot, let us assume this as z, plus a dot z bar. Hence you are supposed to get a XOR z, where z is b XOR b in. So final difference is a XOR b XOR b in. Similarly, borrow. So firstly I am going to write down the borrow statement by shuffling the terms. So I have taken the first term and the last term, you can have a look over here together, and the middle two terms on the side. So from the first two terms, take b in common. So you will get a XNOR b. So this is XNOR. You can have a look over here. Similarly, from the last two terms, you can take a bar b common. Hence, b dash in plus b in is equal to 1 as per the Boolean algebra. The final expression for borrow comes out to be a XNOR b in plus a bar b. Now let us design the logic circuit diagram for that as well. So this is the logic circuit diagram. Till here you are supposed to get a XOR b. So the difference is a XOR b XOR c. Here the c is representing our b in as per the Boolean expressions which we have used. Next is a XNOR b in. So this is the signal which has been given to NOT gate. So this is a XOR b bar. So this is what I am talking about. A XNOR b dot b in. So dot means AND gate. So this is the first expression which has been done by using AND gate. Next is a bar dot b. So here we have taken a given to NOT gate. So this is a bar dot b. So this signal is b, a bar b, and there is a plus in between both. Plus means OR gate. Hence you are supposed to get the borrow logic circuit diagram as well, that is a XNOR dot b in plus a bar b. So this is the final logic circuit diagram for full subtractor. Thank you so much.